Okay, well, let's see, oops. Section 1.5, and this is our infinite limits and graphical. There's not a lot to say here. I think you all get the idea pretty well. If I go to say something like Desmos, and I'm going to actually try that here, you know, I'm just looking at the graph and I am looking for behavior that, you know, maybe does something like this, you know, a vertical asymptote idea there, and you know, if I can find that, then I have a limit, at least one side, because again, right, it could you know, head up that way, but it might head down this way, so you know, I could get an asymptote in something like that. And now you want to be careful with the definition of a vertical asymptote. So, you know, the definition, so I'm going to toss that in here. Definition of vertical asymptote, since we are looking at them graphically. In that definition, if you know, if either the limit as x approaches c from the left of f of x is equal to plus or minus infinity, in other words, it grows without bound in either of those directions, or the limit as x goes to c from the positive side of f of x is equal to either plus or minus infinity, then f of x has a vertical asymptote at x equals c. Okay, and so you know, just to point out that the definition says, you know, here we'll put c about there. That we have, you know, that's showing a vertical asymptote because as x approaches c from the left, we head off toward positive infinity. Similarly, you know, oops, that's not what I wanted there, but you know, if we have something like that, the function may not even be defined over here, then again we have an asymptote at c, because at least one side is heading toward negative infinity in this case, and you know, then of course they could both do it, but they don't have to be in the same direction. So again, if we look back up here, this graph here has a vertical asymptote at that c value, whatever that is, because in this case both grew without bound, but one in the positive direction, one in the negative direction. So none of that, you know, it doesn't really matter, but we could also have the function defined at c, you know, something like this over here, and that's fine. So again, graphically, let's try pulling up Desmos. So I have Desmos here. Let's see how we do. And so I'm not sure what happened. Now that I think about it, I don't know if I might have to do it, you know, something like this. ABC, okay. So, you know, I could say something like F. This is really slow this way, but F of X equals, and I could do, you know, something like 1 over x squared, so 1 divided by x, and then I don't know what happens if I do a squared like that. Great. Okay. And so graphically, you know, I see this thing heading up toward positive infinity as it heads towards 0. And, you know, once I put the graph in, you know, I can check, you know, I think it's at 0, right? You know, so I think it is right at 0. Well, how can I check that? One, I could try tracing, but that would be hard with an asymptote. So I just come over here, and the reason I did the f of x is that then I can come in here and say f of 0, and we see it's undefined. And so I'm pretty sure that is where my asymptote is. Now also I just, yeah, I can do a little algebra and see that that's where I'm dividing by 0. So I think that's going to be it. Okay, so graphically, you know, that's what we do. And you know, if I have something else like g of x. Okay, so g of x is equal to, and I'll do a fraction again, but this time I'm going to do something like, let's see, x squared minus 4. Close that parenthesis, then say divided by, and I'll do an x, oops, lost my stuff there, go back to there, x plus 2. And so, you know, I know that at x equal -2, I'm dividing by 0, but if I look here, oops, okay, so here's x equal -2, you know, I look down here, and I can trace this thing, and of course the function's undefined at -2, but and we could pull this up just a little bit. Okay, so you know, there's -2, you know, coming down here. There we go. I'm not very good at keeping it there, but we see undefined. And, you know, so it's undefined there, but we don't see that behavior of heading either toward positive or negative infinity. And so, you know, graphically, we don't have an asymptote. We don't see one. Okay, so unlike our first function, f of x. So that's the graphics. That's really all there is to it. graphically is just looking for that behavior, and so I think that's good for this. The big thing is realizing that an asymptote, it only has to happen from one side to be called an asymptote.